Welcome to AWS Mastery Labs, turning AWS chaos into clarity with bite-sized tutorials, hands-on labs, and exam-smashing tips. In this video, we'll introduce you to Amazon Kinesis data streams, one of AWS's most powerful services for real-time data ingestion and processing. We'll walk through the core concepts, architecture, and key components of Kinesis data streams while exploring common use cases. Let's get started. As organizations digitize and scale, they're faced with an ever-growing wave of streaming data. Coming from IoT devices, application logs, transactions, social feeds, and user activity across platforms, this data is constant, continuous, and often critical. Today's businesses can't afford to wait. They need to act on data as it happens, whether it's detecting fraud in real time, recommending products to users on the fly, or responding instantly to operational anomalies. The demand for real-time insights is no longer a nice-to-have, it's a competitive necessity. But traditional batch processing systems just aren't built for this. They introduce latency, operate on fixed schedules, and often fail to deliver insights fast enough to drive timely decisions. Building a real-time streaming infrastructure from scratch also presents its own set of challenges. It's complex, resource-intensive, and often involves integrating multiple disparate systems just to get a basic pipeline running. You also need to meet strict performance expectations, processing millions of events per second with minimal delay while ensuring high throughput and low latency at scale. On top of that, the system must guarantee data integrity, ensuring that records are processed in order, without loss or duplication, especially in sensitive domains like finance, healthcare, or security. And since data volumes can spike unexpectedly, your architecture must be elastic, able to scale dynamically without over-provisioning or driving up costs. Finally, all of this real-time data needs to seamlessly flow into your broader ecosystem, whether that's data lakes, analytics platforms, or machine learning pipelines, adding another layer of complexity. Amazon Kinesis Data Streams is a fully managed service that makes it easy to collect, process, and analyze real-time streaming data at scale. It's designed to handle high-throughput workloads with ease, allowing you to ingest massive volumes of continuous data from websites, mobile apps, IOPS, IoT sensors, and enterprise applications without managing the underlying infrastructure. With Kinesis Data Streams, you can capture gigabytes to terabytes of data per hour with latencies as low as a few milliseconds from ingestion to availability for processing. This enables you to respond to events and take action in near real time. The architecture is built to be durable and fault-tolerant, replicating data across multiple availability zones and giving you the flexibility to retain data for up to a full year. This allows for powerful use cases like stream replay, delayed processing, and forensic data analysis. Kinesis scales elastically. You can manually scale your stream by adjusting the number of shards to meet your throughput requirements, or use on-demand mode, which automatically adapts to changes in data volume without any configuration. It also integrates seamlessly with the AWS ecosystem. You can connect your data stream directly to AWS Lambda for event-driven processing, use Kinesis Data Analytics to run SQL queries on streaming data, or pipe it to Amazon S3, Redshift, or OpenSearch for storage and analysis. Kinesis supports multiple types of consumers, whether you need shared throughput or enhanced fan-out for high-performance parallel processing. From clickstream analytics and application telemetry to fraud detection and machine learning pipelines, Kinesis Data Streams empowers you to unlock the value of real-time data with a fully managed, scalable, and reliable streaming platform. Here is an end-to-end flow with Kinesis data streams. On the left, we see the data producers, the first step in the real-time data journey. These include applications, client devices, Kinesis agents, and AWS SDKs, all continuously generating and pushing data into the stream. Think of website clickstreams, financial transaction logs, IoT sensor readings, or application telemetry, any event or action that needs to be captured in real time. Each of these records streams into Kinesis with impressive performance, offering a robust pipeline for even the most demanding workloads. At the core is the Kinesis data stream service itself. Kinesis structures incoming data into shards, each acting like an independent, highly scalable conveyor belt. Shards not only support high ingestion rates but also offer fine-grained parallelism for processing. Need more capacity? simply add more shards. Whether you're running with a handful of shards or scaling up to hundreds, Kinesis dynamically grows to meet your throughput needs while maintaining high availability and durable storage across multiple availability zones. On the right, the consumers take center stage. You can build consumer apps using the Kinesis Client Library, KCL, or AWS SDKs for full control, or trigger AWS Lambda functions to run serverless, event-driven analytics. Services like Data Firehose simplify routing data directly to storage or analytics destinations. And for advanced real-time processing, Apache Flink and Apache Kafka connectors integrate seamlessly, offering stateful computations, windowed aggregations, and complex event processing on the fly. Finally, after the data is processed, it's delivered to key AWS services depending on your use case. Store raw or processed data cost-effectively in Amazon S3, enable fast key-value lookups with DynamoDB, power big data workloads with Amazon EMR, or perform complex analytics with Amazon Redshift. Every part of this pipeline is designed to be elastic, durable, and deeply integrated with the broader AWS ecosystem, giving you a complete real-time data architecture that's powerful, scalable, and ready for the future. At the heart of the system is the stream, an ordered sequence of data records flowing in real time. Streams are the logical containers that hold and organize incoming data from your producers. A stream is divided into one or more shards. Shards are the basic units of capacity in Kinesis. Each shard can ingest up to 1 megabyte per second of incoming data and provide up to 2 megabytes per second of data output for consumers. The total capacity of a stream is the sum of its shards, which makes scaling as simple as adding or removing shards based on throughput needs. When data is sent into a stream, each record includes a partition key. This key determines which shard the record gets routed to. Kinesis uses this key to group related data into the same shard, preserving the order of records that share the same key, essential for processing things like user activity, transactions, or sensor data in sequence. Every record in a shard is assigned a sequence number, a unique identifier that helps maintain order within the shard and supports replay, checkpointing, and fault-tolerant processing. Data is pushed into the stream by producers. These can be applications, mobile devices, servers, or AWS services using the Kinesis API, Kinesis Agent, or the Kinesis Producer Library. Once the data is in the stream, it's picked up by consumers. These are applications that read and process the data. Kinesis also supports data retention, allowing records to be stored from 24 hours up to 365 days. This enables late data processing, replay, and forensic analysis. And finally, checkpointing is critical. Consumers typically keep track of which records have been processed, ensuring data is not missed or reprocessed unnecessarily, enabling robust, scalable, and resilient data pipelines. When deploying Kinesis data streams, AWS gives you two flexible modes to choose from: provision mode and on-demand mode, each optimized for different kinds of workloads. Let's start with provisioned mode. In this mode, you specify the number of shards in your stream based on your expected throughput needs. Each shard gives you 1 megabytes per second for data ingestion and 2 megabytes per second for reading. If your data volumes are fairly steady and predictable, provisioned mode gives you precise control over your stream's capacity and cost. But with that control comes some responsibility. You'll need to monitor your usage and manually scale the stream by splitting or merging shards as your data volume changes. This can mean more operational effort, especially if traffic patterns are dynamic. Now contrast that with on-demand mode, a fully elastic option where AWS automatically scales your stream's capacity in response to the data load. You don't have to define shard counts or worry about scaling operations. Whether your traffic ramps up gradually or spikes suddenly, on-demand mode handles it gracefully, scaling from 0 to hundreds of megabytes per second without intervention. This makes it a great fit for unpredictable or bursty workloads, like gaming telemetry, IoT data, or social media feeds. And since you only pay for what you use, it's cost-efficient for variable workloads. Both modes support all core Kinesis features, including enhanced fan-out, shared throughput consumers, and millisecond-level latency. The real difference is in how you manage and pay for capacity. Choose provisioned mode when you want cost predictability and don't mind managing shards. Choose on-demand mode when you prefer hands-off scaling and flexibility to handle data surges effortlessly. Ultimately, it's about picking the right mode for your workload's behavior and your team's operational preferences. In traditional Kinesis consumer models, multiple applications share the read throughput of a shard. This can quickly become a bottleneck when several systems need to consume the same data stream simultaneously. That's where Kinesis Enhanced Fanout comes in, offering a powerful alternative designed specifically for high-performance, low-latency data delivery. With Enhanced Fanout, each registered consumer gets its own dedicated throughput, up to 2 megabytes per second per shard. This means your applications don't compete with each other for read capacity. Whether you have one consumer or 10, each one gets a private channel of data from the stream. Another major advantage is the push-based delivery model. Unlike the standard model, where consumers pull the stream for new records, Enhanced Fanout pushes data over HTTP2, reducing both latency and overhead. This enables sub-second delivery, often in the range of 70 to 200 milliseconds, from the time data is ingested to when it's delivered to the consumer. It's also important to note that Enhanced Fanout is fully compatible with traditional consumers. You can mix and match both in the same stream. That's helpful if you're migrating incrementally or have legacy systems that aren't ready to move yet. This mode simplifies your architecture as well. There's no need to worry about consumer-side load balancing or managing throughput limits. Each consumer connection is independently managed by Kinesis. So when should you use Enhanced Fanout? It shines in use cases where low latency and concurrent data consumption are critical. Think real-time monitoring dashboards, fraud detection systems, live analytics, alerting engines, or personalization engines that need to respond instantly to incoming data. One thing to keep in mind is that Enhanced Fanout does come at an additional cost per consumer shard combination. So it's best suited for scenarios where the performance benefits outweigh the additional expense. When sending data into Kinesis data streams, AWS provides a variety of producer options, each tailored to different workloads, integration points, and development needs. Let's explore the most common options and when to use them. First, we have the Kinesis Producer Library, or KPL. This is a high-performance library available in Java and C++, designed specifically to maximize throughput into Kinesis. It handles complex tasks like batching, aggregation, and retries behind the scenes. If you're building a custom high-volume producer, such as a telemetry collector or log forwarder, KPL is a powerful choice for squeezing every bit of performance out of your stream. Next is the AWS SDK, which provides native APIs to interact with Kinesis from a wide range of programming languages like Python, JavaScript, Go, and Ruby. This is a great option when you need direct, low-level control over each API call, ideal for lightweight applications or use cases where precise message handling is required. Then there's the Kinesis Agent, a pre-built Java application that you can install on servers or EC2 instances. It monitors log files and automatically pushes new entries into Kinesis. It's a great drop-in solution for sending application logs, server metrics, or other file-based data to a stream with minimal setup. You can also stream data from other AWS services like CloudWatch Logs, IoT Core, or AWS Lambda. These services natively support Kinesis as an output target, enabling event-driven architectures without writing producer code. For organizations with existing streaming infrastructure, third-party connectors like Apache Kafka, Apache Flume, or Logstash can route data into Kinesis, providing seamless integration into hybrid or multi-platform environments. And finally, Data Firehose can act as a simplified producer for Kinesis data streams or other destinations. It automatically batches and delivers data, supports transformation with Lambda, and requires zero administration. When building high-throughput real-time data pipelines, simply writing data to a stream isn't enough. You also need to do it efficiently, reliably, and at scale. That's where the Kinesis Producer Library, or KPL, really shines. KPL is an advanced, high-performance library developed by AWS specifically for writing records into Kinesis data streams. It's designed to take the heavy lifting off your application by handling critical concerns like buffering, batching, aggregation, retries, and network management. One of the biggest strengths of KPL is its asynchronous buffered write model. Instead of sending each record individually, which can create network bottlenecks and API throttling, it aggregates records in memory and batches them based on time or size thresholds. This dramatically reduces the number of API calls and maximizes throughput, allowing you to push tens of thousands of records per second with much greater efficiency. It also supports aggregation of multiple user records into a single Kinesis record. This means you can push more data through a single shard, allowing you to make the most of your provisioned capacity and potentially lower your overall costs. KPL includes built-in retry logic and failover handling, ensuring that your data is reliably delivered even if there are transient issues with the network or the Kinesis service itself. It takes care of partition key assignment too, either based on your logic or automatically, to help distribute load evenly across shards and avoid hotspots. KPL is available in Java and C++, but can also be used in other languages via a native process interface, making it flexible for teams working in diverse tech stacks. In terms of use cases, KPL is best suited for high-throughput, low-latency workloads, like ingesting clickstream data from websites, processing sensor data in IoT environments, or collecting telemetry from distributed applications. The Kinesis agent is a lightweight, Java-based tool that makes it easy to collect and stream data from file-based sources directly into Amazon Kinesis data streams or Data Firehose without having to write a single line of producer code. It's perfect for server-side deployments where logs are generated continuously and need to be ingested in near real time. Installation is straightforward. It runs on most Linux-based environments, including Amazon EC2. Once installed, all configuration is handled via a simple JSON file, where you define the file paths to monitor, the destination stream, and optional processing rules like time-based filtering or data transformation. One of its biggest is its ability to automatically monitor file changes, including support for log rotation. As new entries are added to your log files, the agent detects them and begins streaming them to your target destination. This means you can start streaming log data within minutes of deployment. But it's not just about convenience. The Kinesis agent is also built with resilience in mind. It includes local buffering to handle temporary connectivity issues and features intelligent retry logic to ensure data is not lost during network failures or AWS service interruptions. It also supports record aggregation and compression, helping you reduce the number of API calls and lower data transfer costs, while still ensuring that your data reaches Kinesis quickly and efficiently. The Kinesis agent is ideal for scenarios like streaming Apache or Nginx logs, custom application logs, or audit trails from EC2 instances or on-premise servers. It's a particularly useful choice when you need a low-latency, no-code solution to move logs and events into your AWS data pipeline. When it comes to consuming data from Kinesis data streams, AWS offers a diverse set of options to match different processing models, use cases, and architectural preferences. Let's walk through the most common Kinesis consumer options and when each makes sense. First up is the Kinesis Client Library, or KCL. This is a high-level Java library that simplifies many aspects of stream consumption, like load balancing across multiple consumer instances, checkpointing to track progress, and retry logic for resiliency. It's a solid choice when you're building scalable, stateful streaming applications using Java or JVM-based languages. If you prefer more granular control, you can work directly with the AWS SDK using the low-level Get Records API. This approach gives you full flexibility over how you pull the stream, manage checkpoints, and process records. It's best suited for lightweight consumers or custom logic where you don't want the abstraction of KCL. Next, Enhanced Fanout offers a powerful solution for performance-heavy workloads. With EFO, each registered consumer gets a dedicated read throughput of up to 2 megabytes per second per shard, and data is pushed to consumers instead of being pulled. It's ideal for real-time, multi-consumer architectures where speed and throughput are key. For a fully managed, event-driven model, AWS Lambda can be directly connected to a Kinesis stream. This lets you process records in real time with no server or scaling management. It's perfect for use cases like triggering alerts, filtering data, or executing lightweight transformations. For more advanced real-time analytics, Kinesis Data Analytics lets you process streaming data using either SQL or Apache Flink. You can run continuous queries, detect anomalies, or build near real-time dashboards without managing infrastructure. And finally, Data Firehose can act as a consumer by reading from your stream and delivering data to destinations like Amazon S3, Redshift, or OpenSearch. It's great for simplified ETL pipelines, where minimal code and hands-off delivery is the goal. When building consumer applications for Kinesis data streams, managing shard coordination, checkpointing, and fault tolerance can get complex quickly, especially as your workloads scale. That's where the Kinesis Client Library, or KCL, really proves its value. KCL is a powerful Java-based library that simplifies the development of consumer applications by abstracting away the operational complexity of working directly with the Kinesis APIs. Instead of manually polling for records, tracking shard progress, and handling failures, KCL manages all of that for you, so you can focus on your core data processing logic. One of the most important features of KCL is its automatic load balancing. When you deploy multiple KCL instances, say across different EC2 instances or containers, they collaborate to divide up the work of processing shards. This dynamic distribution not only scales horizontally, but also ensures resilience. If one worker goes down, others seamlessly pick up its workload. KCL also handles checkpointing using DynamoDB. This ensures at least once processing, so your application won't miss or skip data, even across restarts or crashes. You can also control when checkpointing happens, giving you granular control over data durability and replay semantics. Even though the core library is written in Java, KCL supports multi-language environments using a companion process model. That means you can write your actual processing code in Python, Node.js, or other languages, while still benefiting from KCL's robust coordination and fault tolerance mechanisms. Each KCL instance acts as a worker that manages one or more shards. This makes it easy to scale out your architecture and run multiple instances in parallel, whether you're ingesting social media data, enriching customer events, or building real-time analytics dashboards. Now, it's worth noting that KCL uses the standard getRecords API under the hood, which means it's polling based. So while it may not achieve sub 100 milliseconds latency like enhanced fanout, it provides strong guarantees around control, durability, and fault tolerance, which are often more critical for many applications. Shard management lies at the heart of operating Amazon Kinesis data streams efficiently. Shards are the fundamental units of capacity within a stream, and managing them properly ensures your data pipeline remains performant and cost-effective. Let's start with monitoring shard utilization. Using Amazon CloudWatch, you can track metrics like incoming and outgoing byte rates per shard. If you're consistently hitting throughput limits, that's a strong signal. It's time to scale. Which brings us to resharding, the process of adjusting your shard count. Kinesis supports both shard splitting and shard merging. Splitting allows you to double the throughput by dividing a single shard into two, while merging reduces shard count and cost when traffic subsides. AWS provides API-based controls like split shard and merge shards, giving you fine-grained management over your stream. These operations are seamless and happen in the background, ensuring continued data flow without disruption. You'll also want to implement auto-scaling logic where possible. By analyzing throughput patterns, you can automate shard adjustments. While Kinesis doesn't offer native auto-scaling, combining CloudWatch alarms with Lambda functions lets you dynamically reshard based on real-time metrics. A key concept in shard management is the partition key strategy. This key determines which shard a record lands in. A well-designed key distributes data evenly across shards, preventing hot shards that become a bottleneck. If you're seeing skewed distribution, it's likely due to ineffective partitioning. It's also important to note the rate limits around scaling. You can only scale a stream up or down by more than double or less than half of its current shard count once every 24 hours. Planning resharding events ahead of time ensures you don't hit these limits during critical data bursts. Lastly, remember that the maximum shard count per stream is 10,000. While that's more than enough for most use cases, keep this in mind when designing for extreme scalability. When working with Amazon Kinesis data streams, understanding its scaling limitations is crucial for designing resilient and responsive data pipelines, especially at high throughput levels. At the heart of Kinesis scalability lies the concept of shards, each offering a fixed throughput. To handle more traffic, we add shards. But this horizontal scaling comes with several important caveats. First, AWS enforces limits on how quickly and how much you can scale a stream. You can't scale a stream by more than 10x within a rolling 24-hour period. Similarly, you're restricted from doubling your current shard count or cutting it in half in a single step. While this protects the control plane, but can also introduce delays when adapting to spiky traffic patterns. You'll also want to keep your account-wide shard limits in mind. Each AWS account has a quota on the total number of shards across all streams. Hitting this ceiling means you'll need a service limit increase before proceeding. And remember, in provisioned mode, you're responsible for managing shard scaling explicitly through shard splits and merges. These changes can take time to propagate to all consumers, potentially leading to temporary processing delays or duplicate reads. Finally, there's the hot shard problem. Even with many shards, an uneven partition key distribution can concentrate traffic on a few shards, creating bottlenecks while others sit idle. When working with real-time streaming data, security must be built in, not bolted on. With Amazon Kinesis data streams, AWS provides a layered security model that helps you protect data at every stage of its journey. At the foundation is fine-grained access control using IAM roles and policies. These allow you to control exactly who can create, write to, or read from your Kinesis streams. Whether you're managing access across teams or applications, IAM ensures only authorized users and services can interact with your data streams. Beyond IAM, Kinesis also supports resource-based policies. These can be directly attached to individual streams and are particularly powerful for scenarios like cross-account access, enabling secure and flexible sharing of data streams across organizational boundaries. Security continues with encryption, both at rest and in transit. Kinesis offers native server-side encryption integrated with AWS Key Management Service, KMS. This ensures that all data written to a stream is automatically encrypted using keys you control. You can go a step further with custom KMS key policies, which allow for additional, granular control over who can use the encryption keys and under what conditions. All data in transit is encrypted using TLS, providing end-to-end protection from producers to consumers. For workloads that require an even higher level of control, client-side encryption is available, allowing you to encrypt data before it ever leaves your environment. Kinesis also integrates with AWS Private Link, enabling you to use VPC endpoints. This keeps Kinesis traffic on the AWS private network, eliminating exposure to the public internet and significantly enhancing security in regulated environments. Together, these features deliver a comprehensive, multi-layered security model, making Kinesis data streams a trusted choice for secure real-time data ingestion and processing. Kinesis data stream pricing is based on a few key dimensions that align with how you provision, ingest, and consume data. First, let's look at shard hour charges. In provisioned mode, you're billed per hour for each active shard in your stream, regardless of whether the shard is at full capacity or idle. This means over-provisioning shards can quickly lead to inflated costs, so it's important to monitor and scale appropriately. Next up is data ingestion pricing, which applies to both provisioned and on-demand modes. You're charged based on the total amount of data you put into the stream, measured in gigabytes. And this isn't just the raw payload. Charges include the full base 64 encoded record size, including partition keys and metadata. For users leveraging on-demand mode, AWS simplifies provisioning, but charges based on PUT payload units. Here, each 25 kilobytes chunk of data equals one PUT payload unit, and you're billed per million of these units. This is ideal for unpredictable or spiky workloads where auto-scaling removes the need for manual shard management. If you're using enhanced fan-out, EFO, to give consumers their own dedicated throughput channels, keep in mind that EFO comes with a separate charge. Pricing is based on data read throughput per gigabyte and the number of EFO consumers per hour. It's powerful for reducing latency and increasing parallelism, but that capability comes at a premium. Kinesis also allows extended data retention beyond the default 24-hour window. If you retain data up to 7 days, AWS will charge you per gigabyte a month for that extra storage. This can be a worthwhile investment for use cases requiring reprocessing or delayed consumption, but it's important to factor this into your cost model. And lastly, data consumed by standard consumers. The default mode of reading from the stream is also metered. You pay per gigabyte of data read, making it important to optimize downstream processing to avoid redundant reads. As your real-time data scales, even small inefficiencies can translate to significant expenses. First up is shard right-sizing. Shards are the backbone of your stream's capacity, but over-provisioning them leads to unnecessary costs. Use CloudWatch metrics to monitor ingestion and retrieval throughput and adjust your shard count accordingly. Regular splitting or merging of shards based on usage patterns can help maintain the sweet spot between performance and spend. Next, consider the use of Enhanced Fan-Out, EFO. It offers dedicated throughput for each consumer and reduces read latency, but it comes at a premium. EFO is ideal for critical, high-speed consumers, but for less time-sensitive workloads, standard consumers are far more cost-effective. Choosing between on-demand and provision modes is another key lever. On-demand mode is great for unpredictable workloads because it scales automatically. For steady, predictable traffic, provisioned mode offers better control and lower overall expenses. Don't overlook data retention periods. By default, Kinesis retains data for 24 hours, but you can extend this up to 7 days. Be intentional here. Storing data longer than necessary directly increases costs. Set the retention window to match your actual processing needs. Monitoring and alerting is a must-have. Use AWS CloudWatch and AWS budgets to track usage and trigger alerts for unexpected cost spikes or usage anomalies, giving you a chance to respond before the bill grows. And finally, evaluate your architecture. In some cases, alternative services like Amazon MSK, Kafka on EC2, or even EventBridge might provide more cost-effective solutions depending on your throughput, latency, and durability requirements. AWS provides a comprehensive suite of tools to observe and analyze the performance of your streams, helping you maintain uptime, troubleshoot issues, and optimize costs. At the core of KDS monitoring is Amazon CloudWatch, which provides key stream-level metrics such as incoming bytes, incoming records, read provision throughput exceeded, and iterator age milliseconds. These metrics give you insight into ingestion rates, consumer lag, and whether you're exceeding the read or write limits of your shards. For deeper visibility, you can enable enhanced monitoring, which provides shard-level metrics. This is particularly useful for diagnosing hotspots or uneven data distribution across shards, enabling precise scaling and tuning. CloudWatch alarms allow you to take action automatically. For example, if consumer lag exceeds a defined threshold, you can trigger a Lambda function to alert your team, scale shards, or take other automated responses. This ensures your system remains responsive even under heavy load. Logs are another critical part of the observability picture. Many Kinesis producers and consumers, including the Kinesis Producer Library, KPL, and Kinesis Agent, offer built-in logging that can be forwarded to CloudWatch logs. For more advanced scenarios, Kinesis Data Analytics can be used to write real-time SQL queries on your data stream itself. This is a powerful way to detect anomalies or unusual patterns before they affect downstream systems. If you're using services like AWS Lambda or Amazon ECS to consume data, integrating AWS X-Ray can help trace the end-to-end flow of records through your application, surfacing latencies and bottlenecks that CloudWatch alone might miss. And for teams using external observability platforms like Datadog, Prometheus, or Splunk, you can export CloudWatch metrics to visualize, correlate, and analyze your Kinesis performance alongside other parts of your system. Let's walk through some of the most common and impactful scenarios where KDS excels. One of the primary use cases is real-time analytics. Businesses today want insights the moment data is generated. Whether it's monitoring sales performance, tracking operational metrics, or observing traffic patterns, Kinesis enables near-instant processing of data to power live dashboards and alerting systems. KDS is also widely used for log and event ingestion. Microservices, containers, and serverless applications generate massive volumes of operational data. Kinesis can collect logs from these distributed systems and stream them to centralized locations like S3, CloudWatch, or third-party tools for further analysis. Another high-value use case is clickstream analytics. By streaming user interaction data from web and mobile applications, companies can gain deep insights into user behavior, personalize content in real time, and make dynamic UI decisions that improve engagement and conversion rates. IoT data ingestion is another big win for Kinesis. With billions of connected devices generating telemetry data, KDS can serve as the scalable backbone to stream sensor readings, device status updates, and environmental data for real-time processing and analytics. In the financial services sector, Kinesis is used to process real-time market data. Think stock trades, price updates, and fraud detection. These all demand low latency ingestion and reaction times, which KDS is purpose-built to deliver. Security event processing is another area where real-time is mission-critical. Kinesis can capture firewall logs, login events, and intrusion detection alerts, helping security teams identify and respond to threats before they escalate. Kinesis Data Streams delivers scalable, low-latency streaming that powers the modern, data-driven enterprise. When evaluating streaming data solutions on AWS, it's important to understand the distinct roles that Amazon Kinesis Data Streams and Amazon Data Firehose play in real-time data pipelines. Amazon Kinesis Data Streams is designed for real-time streaming data processing with low latency requirements. It's built for highly customizable use cases where you need control over how data is consumed, processed, and distributed. With data streams, you manage the flow of data through shards, a unit of scalability, and are responsible for managing shard capacity, scaling based on your throughput needs, and configuring data retention, which can extend up to 365 days. In contrast, Amazon Data Firehose is a fully managed service that simplifies the delivery of real-time data to destinations like Amazon S3, Redshift, and OpenSearch. With Firehose, you don't need to worry about shard management or scaling. The service automatically adjusts to accommodate incoming data. Firehose is ideal for scenarios where you want to quickly stream data with minimal configuration and management overhead, and you're focused on data delivery rather than complex processing. Another key difference is in the area of data transformation. While Kinesis Data Streams requires you to build custom data processing applications using services like AWS Lambda or EC2, Data Firehose allows you to apply real-time transformations using Lambda without the need to set up complex applications. This means you can easily filter, enrich, and convert data formats, e.g., from JSON to Parquet, on the fly. In terms of scaling, data streams requires manual intervention. You must configure and manage the number of shards required to handle your data's throughput. On the other hand, Data Firehose scales automatically based on the volume of incoming data, making it much easier to handle spikes in traffic without worrying about resource allocation. Both services offer error handling capabilities, but with Firehose, retry logic and automatic error handling are built in, allowing the service to handle transient failures without manual intervention. Data streams, by comparison, requires custom error management strategies. In short, Kinesis Data Streams is ideal for custom processing and low-latency data applications, while Data Firehose excels at simplified, fully managed delivery with automatic scaling and built-in transformations. Thank you for joining us in this video. If you haven't already, we'd love for you to subscribe to our channel to stay updated with our latest content. We look forward to sharing more insights with you in another video. Until then, keep exploring. And thank you for watching.